Okay, we are continuing section 3.1 where we're talking about relations. We're talking about all the different types of relations that we can have. We always have a dependent variable and an independent variable. So we've gone through 4 examples now. I'm going to go through one more example. Number 5. Let's say amount of medication taken, percentage of medication in bloodstream. Okay, so the amount of medication you take and the percentage of the medication within your bloodstream. So I want to not move on from this point until everyone's hand goes up. You can understand which one it is. Okay? Which one are you choosing and which one are you measuring? Should be pretty easy now. Miguel's going to try and guess. Okay? That's one of the few that
So, amounts of medication taken would be
dependent or independent? I wish you said it with a little more certainty, but you're right. So this is amount taken, and this is amount in blood, or percentage amount in blood. So see, even though the units are the same, there's still one that's distinctly chosen. You choose how many pills you want to take. And there's one that's distinctly measured. You have to measure your bloodstream. You can't choose what the concentration is going to be in your bloodstream because it's dependent on how much blood you have, how big you are, versus, etc. All these other factors. Okay, is everyone clear now? What's independent and what's dependent? Yeah. Independent, remember, is on the x-axis or horizontal axis. Independent is what you, dependent is what you measure. And it makes sense that one is going up and down because you're measuring it up and down, right? Whereas the independent just goes straight across. Okay? All right, a couple other definitions. So we got independent, we have dependent. We also need to know discrete as well as continuous. Discrete, what discrete means is a set of data that cannot be broken into smaller parts. So I think the book has cost per window, and then windows clean. And so it graphs a certain line. And then it says, well, this is discrete, so we don't use a solid line for discrete variables or relations. We use a dashed line. Okay? And the reason why is because you can't have half a window clean. Actually, you can, but in the book they're giving that as an example. You wouldn't clean half a window. The example I gave is maybe you're measuring how many homes are in a neighborhood and how many people live in those homes. You never have half a person, 8.5 people. Okay, so maybe this is a better example, way to think of it. It's discrete data. There's gaps that are skipped. So if this is 1, 2, 3, 4, I can't draw a continuous line here because then I'm saying like 3.25 people. Okay, or 3.7 or 3.5. Do you guys understand that? Yeah. That's why this line representing the relation is a dashed line. That's why they dash it. Okay? Whereas when we're talking about a continuous graph or relation, we're talking about it can be broken down into smaller parts and still have meaning. So we can have fractions of a side length, right? We can have 3.2, for instance, side length, and then our volume can also be in fractions. All right, so that we represent, even though we may have only measured, specific locations, we know that we have this continuous relation. Okay? Any questions there? So discrete, continuous, we understand, Michael.
Can't you just identify them by just looking if they have a dash and a straight line?
Yeah, but when you're asked to create them,
so
you're given information. You got to do a table of values, and you do a graph. Yeah. You have to know whether to do a dashed line or whether you do a continuous line. Okay. But yeah, you're right. If you're just looking at two graphs, you can tell by that. And the last one is interpolate. We need to know what that means. What interpolate means is that you have two values. So let's say our side length, we have 1, 2, 3, 4. We have a side length here of 4 and a side length of 5, 6, 7 here. Okay? And it says, what's the volume going to be at a side length of 6? So you're going to find 6, here's 6, there's your side length of 6. Go up to the graph, and now, so we know that point on the graph, we're going to interpolate back and then tell us what the volume is here. Okay, so that's what interpolation means, is that you have two known points and you're figuring out information between those points by interpolating. Okay, any questions about that? So we're very clear on those word definitions. Yes? Okay, moving on. Let's go to some of the examples. First one I'm going to look at is page 144, example 2. It says determine the volume of a cube with a side length of 2.5. So we have, we can create a table of values here. So most of you know the formula for volume, and if you know it's a cube, you know, even from the last test, you should know the equation length times width times height. But just for the purpose of this section of the textbook, they ask you to estimate using a graph. Okay, actually, Pilar's solution, the next solution, just calculates it directly. Actually, I would prefer to use that because the graph is a little. It's showing you how to interpolate, but for the purpose of this question, it just say determine the volume of a cube with side length 2.5. Let's just use Pilar's solution because I think it's quite a bit easier. Our side length is 2.5. Our volume is going to be our side length cubed. So we have 2.5 cubed, 2.6. Okay, this is example 2. Hopefully we can show you a better example to use a graph when needed. Example 3, it says the equation V equals 2500 minus 15t represents the car value after t years. It says using technology, so you would actually require a graphing calculator to do this one. So I'm going to skip that one for now. You can get one from your homework. Look at number 10 in the homework. Just to give us one more example. It says Antoine charges $5 per hour plus a flat fee of $8 in his lawn mowing business. Describe the relation between earnings and hours using the equation. So if E is his earnings, we can say his earnings is equal 5 times the number of hours plus his flat rate of $8. Alright, so that would give us our equation. And then it says justify your choice of independent and dependent variables. So his earnings and his hours, these are the two variables. Remember, variables refers to the letter in an algebraic equation. So if we're trying to decide what is he measuring and what is he choosing, okay, you can tell me what's independent and what's dependent. How would I graph this? Mark.
Hours is independent.
Good.
And earnings is dependent.
Good, because earnings he needs to calculate using this formula, and hours is the amount of hours he chooses to work. You might say he might not choose his hours, it's dictated by the job, but then you could argue also that he's choosing which job to work. Okay, so he's choosing his amount of hours. Whereas his earnings are very clearly not chosen, they're based on the number of hours he works. Okay, so they're calculated. They're for every definition calculated.
And you can kind of control how many hours. Let's say if you want to work more, you can seek more overtime for that.
Yeah, he chooses to work more hours, exactly. Any questions on that? Okay, very important concept. Independent and dependent. It does last throughout the 4 grades here in high school and on to university, so you need to be very familiar with that. Okay, that's the end of 3.1.